Welcome to ISINTC, IT Infrastructure and Network Technologies. Module 3, ISO or OSI Model. The International Standards Organization or ISO, Open Systems Interconnect OSI, is a standard set of rules describing the transfer of data between each layer in a network operating system. Each layer has a specific function, that is in terms of, for example, physical layer that deals with the electrical and cable specifications. The OSI model clearly defines the interfaces between each layer. This allows different network operating systems and protocols to work together by having each manufacturer adhere to the standard interfaces. The application of the ISO OSI model has allowed the modern networks that exist today. There are 7 layers in the OSI model. We have the physical layer, the data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Physical layer establishes the physical characteristics of the network, that is in terms of the type of cable connectors and the length of cable. This defines the electrical characteristics of the signals used to transmit the data. This is in terms of signal voltage swing, duration of voltages, and etc. Physical layer also transmits the binary data or bits as electrical or optical signals depending on the medium. So the purpose of the physical layer is in terms of the infrastructure. This is the physical hardware of the internet. Wires or optical cables or wireless links and other technologies provide a way for transmission of raw bits, that is in terms of zeros and ones. Routers and switches connect these cables and direct the traffic. Data link layer defines how the signal will be placed on or taken off the NIC. The data frames are broken down into individual bits that can be translated into electrical signals and sent over the network. On the receiving side, the bits are reassembled into frames for processing by upper levels. Error detection and correction is also performed at the data link layer. If an acknowledgement is expected and not received, the frame will be resent. Corrupt data is also identified at the data link layer. Because the data link layer is very complex, it is sometimes divided into sublayers. The lower sublayer provides network access, and the upper sublayer is concerned with sending and receiving packets and error checking. The purpose of the data link layer is to provide basic connection between two logically connected machines. Also send raw packets between hosts, basic error checking for lost data. In TCP/IP, the physical layer and the data link layer are grouped together and called the host to network layer. Network layer, primarily concerned with addressing and routing. Logical address in terms of IP address are translated into physical address, that is in terms of MAC address, for transmission at the network layer. On the receiving side, the translation process is reversed. Network layer is the network wherein the route from the source to destination computer is determined. Routes are determined based on packet addresses and network conditions. Traffic control measures are also implemented at the network layer. The purpose of the network layer is to provide end-to-end communication between any two machines. It also tells data which link to travel down, address the problem known as routing, deals with the question, where do I go next to get to my destination, and ensures that packets get from source A to destination B. Transport layer. On the sending side, messages are packaged for efficient transmission and assigned a tracking number so they can be reassembled in proper order. On the receiving side, the packets are reassembled, checked for errors, and acknowledged. Performs error handling in that it ensures all data is received in the proper sequence and without errors. If there are errors, the data is retransmitted. So for the purpose, it ensures that data gets between A and B. It also ensures that a data gets between source and the destination. If necessary, ensures that connection is lossless or there might be a resending of the missing data. It provides flow control if necessary, meaning it sends data faster or slower depending on the network conditions. Session layer. It is responsible for establishing, maintaining, and terminating a connection called a session. A session is an exchange of messages between computers or dialogue. Managing the session involves synchronization of user tasks and dialogue control. Synchronization involves the use of checkpoints in the data stream. In the event of a failure, only the data from the last checkpoint has to be resent. Log-on, name recognition, and security functions take place at the session layer. The purpose is to provide a single connection for one application. This connection may be two-way or may be synchronized. Presentation layer. It is responsible for data translation or formatting, compression, and encryption. The presentation layer is primarily concerned with translation, interpreting, and converting the data from various formats. For example, ISINTC characters might be converted into ASCII. It is also where data is compressed for transmission and uncompressed on receipt. Encryption techniques are implemented at the presentation layer. The redirector operates at the presentation layer by redirecting input-output operations across the network. So the purpose is to provide commonly used functions for applications. The main job of the presentation layer is to ensure that character sets match. That is in terms if the Chinese characters are correctly received by the sender. Provides the operating system with direct access to network services. It also serves as the interface between the user and the network by providing services that directly support user applications. Application layer. Purpose. The computer programs which actually do things with the network. For example, your email client program which will talk to the email server at the other end. At this layer, we have many protocols such as HTTP, SNMP, SMTP, FTP, and Telnet, which different bits of software use. We often talk in terms of client and server architecture for the software. Simple Network Management Protocol or SNMP is an Internet Standard Protocol for managing devices on IP networks. Devices that typically support SNMP include routers, switches, servers, workstations, printers, modem racks, and more. It is used mostly in network management system to monitor network-attached devices for conditions that warrant administrative attention.